Chapter 6.2, use proportions to solve geometry problems. So in the last section, we learned about cross multiplication. Okay, there are some other things you could do when you have a ratio and proportion. Number one, you can take the reciprocal of both sides. So if you have A over B equals C over D, you can take the reciprocal and get B over A, and you can take the reciprocal and get D over C. All right, the reason this works is because the cross products are still the same. Right here you have A times D, and right here you have A times D, and right here you have B times C, right here you have B times C. So the cross multiplication is still the same when you take the reciprocal. Number two, you can interchange either diagonal. Okay, so again, A over B equals C over D, and you could change or interchange B and C. You can put the B here, and you can put the C here. Okay, and that's what they did. And the reason for that is, once again, the cross product is still the same. Here you have A times D, A times D. Here you have B times C, C times B. So that's the same thing. Finally, number three, you can add each denominator to its respective numerator. Okay, again, A over B equals C over D. You can take the denominator B and do A plus B. But you also have to take the denominator D and do C plus D. So that's going to be A plus B over B equals C plus D over D. All right, so you have to take each denominator and add it to the respective numerator. And again, that is a legitimate ratio and proportion. Example 1 in the diagram, Mn over Rs equals Np over St. Write 4 true proportions. All right, so what I'm going to do is look at the diagram and fill in the values here. All right, so we have two sets of triangles. We see Mn is 8. So I'm just going to put an 8 right here. All right, we see Np is 4. So I'm going to put a 4 right here. Rs right here, that's 10. Just put a 10 right here. And finally, St is this right here, that's X. So I'll put an X right there. All right, so we have two side lengths from each triangle, and we filled them in the proportion. Okay, and they want us to write 4 of them. So let's try to do that. All right, 4 proportions. Number 1, we already have it. That's going to be 8 over 10 equals 4 over X. All right, 8 over 10 equals 4 over X. And we got the first one just by filling in the values. On the second one, we said before you can take the reciprocal of both sides. So 8 over 10 becomes 10 over 8. 4 over X becomes X over 4. So there's 2 of them. Number 3, we said you could interchange the numbers in the diagonal. Okay, so I'm going to reverse or interchange the 4 and the 10. So I'm going to do 8 over 4. And the 10 is now up here. That's going to be 10 over X. All right, so you could do it with this diagonal, or you can do it with the other diagonal, or you can do it with both of them. Either way would work. Finally, number 4. For the last one, we said you can add the denominator to the respective numerator. Okay, so taking this denominator It's going to be 8 plus 10. And that's still over 10. And over here, the denominator is x, so it's going to be 4 plus x divided by x. All right, so there's your 4 proportions based on the original. Example 2, in the diagram BD over DA equals BE over EC, find BA and BD. Let's take a look. All right, so here's our diagram, and we do not have BD. Okay, you can certainly make it x minus 3, but this length x right here, that's going to be BD plus DA. So x actually equals BD plus DA. That equals x. So what we could do to the ratio and proportion that they gave us, we can change it. Okay, we said you can add each denominator to the respective numerator. So this is going to be BD plus DA. And that's still over DA. And that's going to equal BE plus EC. And that's still over EC. All right, and we said BD plus DA right here, that equals x. So in this numerator, that's an x. And DA, we can see right here, that's 3. On the other side, BE plus EC. Here's BE. Here's EC. So it's going to be 18 plus 6 for this right here. And EC is just 6. All right, so you could multiply both sides by 3, okay, but they want us to cross multiply. Anyhow, 18 plus 6 is going to be 24. 18 plus 6 gives us 24. All right, and if we cross multiply, top times bottom is going to be x times 6. Bottom times top is 3 times 24. All right, solving for x, the opposite of times 6 is divided by 6. Cancels here. Reducing 24 divided by 6 is just 4. And 3 times 4 equals 12. So that equals x. All right, they wanted us to find BA and BD. So let's see, we said x is 12. All right, and this whole thing right here is BA. So BA is going to be 12. And as far as BD, which is this segment right here, that's going to be this whole thing, which we said was 12, minus this piece right here, which is just 3. So BD equals 9. All right, so that's it. They asked for BA and BD. BA was the whole thing. That was the same as X. We solved for X and got 12. And then BD was just this one up here, 12 minus 3. Example 3, the blueprint shows a scale drawing of a cell phone. The length of the antenna on the blueprint is 5 centimeters. The actual length of the antenna is 2 centimeters. What is the scale of the blueprint? All right, let's take a look at the drawing first. All right, there's really no measurements on the drawing here. It's just a blueprint of a cell phone. So let's stick with the write-up. All right, so to find the scale, you want to make a ratio. All right, in ratio, typically it's a fraction. At least that's how I like to write it. So what we're going to do for the scale of the blueprint, we're going to put the blueprint in the numerator. And then we will put the actual length in the denominator. Okay, and then you just want to reduce until you get a 1. So for the blueprint, they said the antenna on the blueprint is 5 centimeters. So for the blueprint, that's going to be a 5 centimeters. And then the actual length of the antenna is 2 centimeters. All right, so you just reduce until you get a 1. Okay, this one's pretty easy. 5 divided by 2 is 2.5. But you need a ratio, so you have to keep it as 2.5 over 1. And that's basically it. You can keep the units if you want to, but you don't even have to because the units match. So you can make it inches or feet or whatever, but since they started with centimeters, I guess we should just keep centimeters. So that's basically it. You basically reduce until you get a 1 on either side. Okay, so they said the scale is 2.5 centimeters to 1 centimeter. I'll just say reduce until you get a 1. Okay, just from their example, apparently you can get a 1 on either side. All right, guided practice in example 1, find the value of x. So let's take a look at example 1. All right, here's example 1, and I think this one right here is the simplest version. So just see if you could do it in your head. See if you can find the value of x. All right, you can certainly cross multiply if you want to. Okay, but I can see right here to go from 8 to 4. Basically, you would divide by 2. So if I were to go from 10 to x, I would once again divide by 2. And 10 divided by 2 is just 5. So that's how I would do it. If you can't do that, then just cross multiply and solve for x. Number 2, in example 2, DE over AC equals BE over BC. Find AC. Okay, let's go to example 2 and I'll write this on by the diagram. All right, so this was given here and they want us to find AC. All right, actually I'll just label that with an X instead of a question mark. All right, that length is X. See if you can solve for x. It's pretty easy. All right, if I were to fill in the values, DE is right here. That's a 12. So I'll just put a 12 right there. BE is right here. That's 18. So I'll just put in an 18 right there. AC, we don't know. So I'll just call that X. And BC is the whole thing. So that's going to be 18 plus 6. All right, and from there it's pretty easy. 18 plus 6 is just 24. All right, and if you cross multiply, top times bottom is going to be 12 times 24. Bottom times top is going to be X times 18. The opposite of times 18 is divided by 18. Cancels here. And reducing, divided by 6. 12 divided by 6 is 2. 18 divided by 6 is 3. 24 divided by 3 is 8. And you're left with 2 times 8. And we said X equals AC. That's what they asked for, AC. All right, number 3. In example 3, suppose the length of the antenna on the blueprint is 10 centimeters. Find the new scale. Okay, let's go back to that example. And let's say the blueprint length is 10 centimeters. So let's try it again and find the new scale. All right, it's pretty easy, I think, but they said the blueprint length is now 10 centimeters instead of 5. So what would the new scale be? I think you could do it in your head. All right, of course, 10 divided by 2 is just 5. So the numerator would be a 5 now instead of 2.5. And it's the same thing. As far as the units, they're still centimeters. So it's basically 5 centimeters to 1 centimeter. All right, pretty simple. Example 5, you buy a 3D scale model of the Reunion Tower in Dallas, Texas. The actual building is 560 feet tall. The model is 10 inches tall. And the diameter of the dome on your scale is about 2.1 inches. What is the diameter of the actual dome? All right, so the picture doesn't really show any measurements or anything, so that's useless. Let's stick with the write-up. So remember in the previous example, we did the blueprint in the numerator and the actual in the denominator. So let's stick with that. All right, in this case, we don't have a blueprint, but we have a model. So I am going to put the model in the numerator. And then on the denominator, I'm going to put the actual length. All right, so I highlighted it in different colors. The actual building is 560 feet. So in the denominator, I'm going to put 560 feet. And then in the numerator, it says your model is 10 inches tall. So I'm going to put 10 inches in the numerator. All right, and it says the diameter of the dome on your scale model is 2.1 inches. So I guess I'll highlight that in the same color. Diameter on your scale model is 2.1 inches because I highlighted the model in pink for the other part of it. All right, so I guess for the height and the diameter, the ratios are still going to be the same. All right, so now The diameter on the model is 2.1 inches. And we want to know the diameter of the actual dome, so I'm going to put that in the denominator. Now, the numerators are in inches and the denominators are in feet. Normally before, when we reduced fractions or ratios, we had to make the units match. But in this case, the units have to match from numerator to numerator and denominator to denominator. Okay, so we're actually okay. All right, so cross multiply 10 inches times x feet. Okay, you don't necessarily need the units every time, but I'm going to show you just to prove that it works. 10 inches times x feet is going to equal, cross multiply, bottom times top, 560 feet times 2.1 inches. All right, and now it's simple. Solving for x, we have x times 10 inches. The opposite is going to be divided by 10 inches on both sides. 10 inch over 10 inch cancels. Inches over inches cancels, and 560 divided by 10 is 56. Okay, and all we have left is to multiply 56 times 2.1, and the units should be in feet. All right, and I get 117.6. All right, so that's the same thing they got. They said it's about 118. I got the same thing. Part B, about how many times as tall as your model is the actual building. All right, so let's see. I'm going to put, since I want to find out how many times taller as your model is the actual building, I am going to put the larger, or I could say greater number in the numerator and the lesser number in the denominator, since I want to know how many times bigger it is. All right, of course, the greater number is the actual building, and the smaller number is the model. All right, so what was the actual building? That was 560 feet. And how tall was the model? Well, it said the model was 10 inches tall. All right, and now, since we want to know how many times bigger it is, the units do have to match. So how do we convert feet to inches? Well, you just multiply by 12. Okay, if you want to see the longer way, we want the units to cancel. And we know 1 foot is 12 inches. All right, so we can put one over the other since they're equal. Okay, here I have feet in the numerator, so I want feet in the denominator. So 1 foot is on the bottom. Here I have inches in the denominator. I want inches in the numerator right here. See, I put one over the other because they're equal. All right, and now the units cancel. Inches divided by inches, and feet divided by feet, and 560 divided by 10 is just 56. All right, so the only thing left is 56 times 12. And I get 672. No units, because they just asked us how many times bigger it is. All right, please try guided practice problem number 4. 2 cities are 96 miles from each other, and they're 4 inches apart on a map. Find the scale of the map. All right, so basically it's pretty simple. Just reduce that fraction until you get a 1. All right, so usually we put the blueprint or the model or the map in the numerator. So I'll put the map in the numerator, and I'll put the actual distance in the denominator. All right, on the map, the cities are 4 inches apart. And the actual distance is 96 miles. All right, so pretty simple. Both of these are divisible by 4. Okay, 4 divided by 4 is just 1. And 96 divided by 4 is just 24. So the ratio is 1 inch to 24 miles. All right, in other words, 1 inch on the map is 24 miles in real life. Last one, number 5. Your friend has a model of the reunion tower that is 14 inches tall. What's the diameter of the dome on your friend's model? Okay, let's go back to that other example and fill in that the model is 14 inches tall. All right, last one. It says your model is 10 inches tall, and the diameter of the dome on that scale model is 2.1 inches. Okay, and now we're saying that the friend's model is 14 inches tall. What's the diameter on the friend's model? See if you could do that. All right, so it doesn't matter which one is in the numerator or in the denominator. So I'm going to put your model in the numerator, and I'm going to put your friend's model in the denominator. All right, so the friend's model is 14 inches tall. And it says your model was 10 inches tall. All right, so the first fraction is the height. And then the next fraction is going to be the diameter. Okay, the diameter on your model is 2.1 inches. And on the friend's model, we don't know. We'll just call it X. All right, so that fraction is the diameter. And from there, it's easy. All the units are in inches, so X is also going to be in inches. If you cross multiply, I'll do it in a different color. 10 times X is going to equal 14 times 2.1. Solving for X, the opposite of times 10 is divided by 10. You do that to both sides. And then 14 times 2.1 divided by 10. And I get 2.94. And we said the units would be in inches. Does it make sense? Yes, if your friend's model is a little bit taller, the diameter is going to be a little bit more.